welcome to everyone to this webinar on cholesterol. And the question we are asking is it really that bad? So it's mid-December 2022, and it's really lovely to have so many of you join us. I thought that by now most of you would be hanging out on a beach somewhere, including myself. But it's lovely to be here, and I'm really excited to share with you what I found after researching this topic. It's quite an interesting one. So just a bit of a disclaimer. So I'm not a medical doctor, and I'm not giving you any medical advice. I'm just sharing some of the latest research on the topic. So please do feel free, I encourage you to also do your own research. And remember that whatever I'm sharing with you today is not necessarily the complete answer, right? But what we do know is that cholesterol has been bad-mouthed for quite a few decades, actually. And while it was not necessarily completely fair, so I am going to look at the defense of why it might have been a bit misguided. And I think often, only even the sheer mention of cholesterol makes people shudder, and, they start worrying about and thinking about how, they could die from a heart attack. And even though there might be some truth to it, it definitely is not the whole story. So I want to share with you today some of my findings. So the question that we are trying to answer this afternoon is cholesterol really that evil as it's been made out to be? Right, so I'm Zena le Roux. I'm a health journalist. I specialized in functional nutrition. Also a health coach with a practice in Pretoria, South Africa. And I'm also an HCA health and nutrition trainer. Okay, so let's start. So I want to start out by just sharing some information on how important cholesterol is, right? It's very important to know that it absolutely plays a crucial role in the body. And so much so that if we had none, we won't survive. And that's important to understand, because we know that cholesterol is beneficial to the heart, the kidneys, the liver, the reproductive organs, our vision, the brain, normal growth, proper function of the nervous system, and it even offers protection from disease. And when I'm saying cholesterol, I'm not just referring to HDL, which is known as the good cholesterol. I'm actually also referring to LDL, which is known as the bad cholesterol. And I'll get into more detail around that a bit later. But for now, just note that it's not just HDL or the good cholesterol that's beneficial, but also the so-called bad cholesterol. Okay, so let's just get into a bit more details with regards to why I'm saying this. Why is it that cholesterol is essential for proper function in the body? So firstly, it supports the immune system. So there's quite a few studies out there that have demonstrated that our immune cells rely on cholesterol. That's when they're fighting infections, but also when they are repairing themselves after the fight. And yes, specifically LDL, our low density lipoprotein, the bad cholesterol, plays a very important role as it directly binds and inactivates dangerous bacterial toxins, so preventing them from doing any damage in the body. So it really makes a lot of sense that it has been recorded that people with high levels of cholesterol seems to be more protected from infections. They rarely get common colds, they recover from infections more quickly compared to people with normal or low blood cholesterol. So quite an interesting statistic there. Okay, the second thing that I want to touch on is the structural integrity. So cholesterol also plays a very important role when it comes to structural integrity, because both cholesterol and saturated fats make the membranes of our cells firm. So without them, the cells would be flabby and fluid and kind of non-existing. So very important role there as well. And we also know that cholesterol supports the health of our neurons. And actually that the highest concentration of cholesterol is in the brain. So about 25% of all cholesterol is accounted for by the brain. And what cholesterol does in the brain is one of the things that it does is it helps with the process of making new synapses in the brain. And your synapses is basically where the brain cells establish the connections with each other, right? So it's been found that the more healthy synapses a person's brain can make, the more mentally able they are and intelligent that person seems to be. So crucial, right? And synapse formation is almost entirely dependent on cholesterol. Okay, so without the presence of cholesterol, we cannot form synapses, and therefore we would not be able to learn or remember anything. Right? So yeah, that's quite interesting. And if you link it up with a very common side effect that have been reported with cholesterol lowering drugs, one of which is memory loss. So, that would really make a lot of sense to me, that if we're lowering the cholesterol, then it is going to impact the memory in some or other way. And there's even some research showing that seniors with the highest cholesterol levels have the best memory function. Okay. So let's look at the next element. So hormones and vitamin D. So cholesterol is also responsible for creating our hormones, because it's the building block that is needed to create our hormones, such as our estrogens, our testosterone, progesterone, but also vitamin D. So some of you might be familiar with, in some circles, they're even saying that vitamin D is a hormone, right? So that's why I'm grouping them together here. But after the brain, the organs that are hungriest for cholesterol are our endocrine glands. So our endocrine glands are the adrenals, that releases the stress hormones, and also the sex glands, because they both produce steroid hormones, and steroid hormones are made from cholesterol. Okay. And also, like I said, vitamin D is made from the cholesterol in our skin when it is exposed to sunlight. So it's another very important role that cholesterol plays over here. Okay, and cholesterol also helps with the digestion and absorption of fats, and specifically our fat-soluble vitamins. So that's A, D, E, and K, right? That's the fat-soluble vitamins. And because it helps with the production of bile acids. So for those of you who are not familiar with bile, so bile basically emulsifies fats. So in other words, it mixes them with water, so that the digestive enzymes can get to them in order for it to be absorbed. Okay, and the very last element that I want to touch on here is the developing brain and eyes of the fetus and of a newborn infant, because it specifically requires large amounts of cholesterol. And that's why it's also very interesting to note that human breast milk provides a lot of cholesterol once again. So it's such a natural and a necessary component. And not only that, but there's also a very specific enzyme in mother's milk that allows the baby's digestive tract to be able to absorb almost 100% of that cholesterol, right? And that is because the developing brain and the eyes of an infant require large amounts of it. And just an interesting fact here as well is that the composition of human breast milk contains about 48% saturated fat, right? And that's the type of fat that has been demonized, but still it's the very first thing in a very natural way that we are fed, right? So how does it make sense? It's a bit, there's a few questions that comes up around this topic. Okay, I just want to see if there's maybe anything in the chat box. Just want to see that everything's fine. Okay, so if cholesterol is beneficial to us, then why has it been demonized over the last few decades? And how did the whole cholesterol hypothesis develop? And that is what I'm going to share with you next. Okay, so So one of the key figures in cholesterol, and you might have heard about him, was Ansel Keys. And he first came up with the hypothesis quite a few decades ago in the 1940s. And he basically said that, saturated fats are bad for health. They cause cholesterol. Cholesterol causes heart disease. But what was interesting about his method of research was that he included 22 countries in his study. But there was only 7 of them that showed a positive correlation between eating saturated fats and it increasing cholesterol and that relating to heart disease. So only 7 out of the 22 countries showed a positive correlation here. So he decided, very scientific, was to throw out the rest. So he stick to his 7 countries. He showed where the positive correlation was showed. And the rest, the other 15 countries, there was either a neutral finding or, it showed the opposite. He just kind of threw that out. So his hypothesis spread the world and across the world and somehow achieved the status of inarguable fact, right? On par with maybe something like moon orbits Earth. You can't argue against that fact. But what was interesting about this is that when he first came out with this whole hypothesis, it was 1948, he did not even know that there was such a thing as a low-density lipoprotein, so LDL, the bad cholesterol, and all of that, because that research only came out much later. At that stage, they were just lipoproteins, and they were all just lumped together and called cholesterol. Which means that Keys had no real idea about fat metabolism or how lipoproteins were made or what controlled their levels. All that he had was the answer, and his answer was saturated fat raises cholesterol level and causes heart disease. And after that, the single most important event in demonizing saturated fat was in 1977 with Senator McGovern's Dietary Committee, where various experts met up and they laid down dietary guideline rules for the prevention of heart disease. And then one of these recommendations were to cut saturated fat from the diet because of Ansel Keys' hypothesis. But what's important to note here is that it really was challenged at that time. It was challenged by many scientists because the findings they found were not based on sufficient evidence. And there's a specific recount of Dr. Olson where he had an exchange with Senator McGovern, which he said, I plead in my report and I will plead again orally here for more research on the problem before we make announcements to the American public. And then Senator McGovern replied, senators don't have the luxury that the research scientist does of waiting until every last shred of evidence is in. So the dietary guidelines were really taken up enthusiastically all over the world, despite the sufficient evidence and in the absence of the very important supporting evidence from our randomized controlled trials. They are, for those of you who know, they are considered the gold standard form of medical research. And that's the type of research that can either confirm or refute your hypothesis. And that was not done at that stage. And they decided to introduce it to the public in any case. So it was based then it was based on nothing more than a tentative scientific hypothesis. Okay. And then also what's quite interesting is that another landmark study was used, or that's often used in the cholesterol research, is a study done on rabbits. So the rabbits were fed cholesterol, and then they quite rapidly developed heart disease. And then they came to the conclusion that, okay, so cholesterol does indeed cause heart disease. And at that time, it was considered an amazing discovery. But you can see the flaw, can't you? It's quite a big one. Rabbits are herbivores, right? So they only eat plants. So cholesterol and saturated fats come from animal foods. Humans are omnivores, so we eat meat and plants and all of that. So feeding rabbits cholesterol when they're not genetically designed to metabolize animal fats and are fed something that is inherently toxic is far from proof that excess animal fat would do the same to humans. Okay. And also they were fed a chemically prepared cholesterol. So it wasn't even a natural form of cholesterol. So it probably also oxidized before the animals consumed it. Okay. So you can see that there were quite a few assumptions that have been made over the years, especially in the beginning. So once again, I'm not saying that there's no truth to it, and definitely once again recommending that you do your own research, because there are a lot of reputable people out there still who do still believe that cholesterol is to be feared. And I think that we also need to give them their due as well. But like I said, today we're focusing on defending the case for cholesterol. So two other studies that I just want to share with you that I find is quite important is the first one. You can see here they've assessed 140,000 people who were admitted with heart attacks in the USA. And what was revealed was that the average LDL cholesterol of those admitted was lower than that of the general population. So they were admitted for heart attack. You know, there's no hypothesis, no thinking that it might cause heart attack. They were admitted for heart attack, and their LDL levels were lower than the general population. Quite an interesting statistic. And then the last one here is the Women's Health Initiative. And it's also a very large contemporary study where they included like 49,000 women, and they followed them for 8 years. And what it demonstrated was that the risk for heart attack and stroke was unaffected after 8 years on a low-fat diet. So once again, there was no link. And yeah, quite a large study, so it's quite a reliable one as well. Okay, so let's go into the mechanisms of cholesterol next to try to figure out how it works. And maybe this could help us to get a bit of a better understanding of how to judge the situation. So let's start with the difference between LDL and HDL. So firstly, we have to understand that cholesterol cannot float free in the blood because it is not water soluble, and therefore it cannot be blood soluble. So cholesterol needs to be transported, and it is transported by teeny weeny little spheres called lipoproteins. Okay. The smallest is called a high density lipoprotein. So that's our HDL. Okay. And that is, that's an LDL, the one that's currently blamed for cardiovascular disease, is known as, it is also another sphere, or almost like a taxi, you know, it transports the cholesterol. And even though it's often referred to as good and bad cholesterol, it's not cholesterol at all. It's the minute lipid and protein sphere that carries the cholesterol within it, among many other things. So it's not just that it carries only cholesterol, it carries a lot of other things as well. But the question is that why do some people have more cholesterol in their bloods than others? And why can the same person actually have different levels of cholesterol at different times of the day? No? So we know that even that our cholesterol levels can differ in different seasons of the year. So sometimes it tends to go up in winter, and in summer it goes down. And we also know that it goes through the roof in people after they've had surgery, or even an infection or some dental treatment. It even goes up when we're under stress. And it tends to go down to normal when we are relaxed and we feel well. So why is this? And the answer to all these questions is that cholesterol is a healing agent in the body. Okay? So when the body has some healing jobs to do, it produces cholesterol and it sends it to the site of the damage. Okay? And something else we need to understand is that the insides of our blood vessels are covered by a layer of cells that's called the endothelium. You might have heard about this before, but any damaging agent, so this could be a toxic chemical, it could be an infectious organism, a free radical, anything else, will always attack the endothelium first. It's the first line of contact. So as soon as the endothelium is attacked, what it does is it sends a message to the liver. And whenever our liver receives that signal that there's some damage to the endothelium, it gets into gear and it sends cholesterol to the site of the damage in a shuttle, little taxi called LDL. Right? And because this cholesterol travels from the liver to the wound in the form of LDL, our science in its wisdom calls LDL bad cholesterol. And then when the wound heals and the cholesterol is removed, it travels back to the liver in the form of HDL, good cholesterol, right? So I find this quite funny because it's almost like when you're calling an ambulance that's traveling from the hospital to the patient, that's a bad ambulance, right? But when it's traveling back from from the patient back to the hospital, then it's a good ambulance. So it's quite a bit misguided, I find. So why does the liver send cholesterol to the site of injury? This is because the body cannot clear an infection, it cannot remove toxic elements, cannot heal a wound without cholesterols and fats, like I've explained earlier with the immune system, right? And when cells are damaged, they require cholesterol and fats to repair themselves. And it's like I've mentioned just now, it's a scientific fact that any scar tissue in the body contains good amounts of cholesterol. And that's why after we've had surgery and there's maybe our tissues are cut, the arteries, the veins, the capillaries get damaged, then the liver receives that very strong signal. So it floods the body with LDL cholesterol to clean and to heal every little wound in our blood vessels. So that's why the blood cholesterol goes high after any surgical procedure. So when we have a high blood cholesterol level, it means that the body is dealing with some kind of damage. And the last thing we should do is to interfere with this process. Because when the damage has been dealt with, usually the blood cholesterol will naturally go down. Unless, of course, we have an ongoing disease or there's maybe some chronic low-grade inflammation in the body that constantly inflicts the damage, then the blood cholesterol might stay permanently high. So when a doctor typically finds cholesterol in a patient, what I think should also be important is to really look for the reason, asking and figuring out what is damaging the body so that the liver has to produce all the cholesterol to deal with the damage and not just attack the cholesterol, right? Okay, so if there's damage in the body, our cholesterol levels will go up, right? So I think a good question to ask here is what causes the damage and what are the real culprits then, basically? And how can we treat the root cause of the problem instead of just blaming cholesterol for the crime just because it was found at the scene? So just because LDL was at the scene of the crime, it doesn't mean it's the perpetrator, right? So Harvard researchers have discovered that a high blood level of C-reactive protein, so that's a marker of inflammation, is actually much more predictive of heart disease than cholesterol. Okay, so inflammation is quite a big culprit because inflammation damages the arteries, and that is one of the reasons why cholesterol might be sent to that site. Okay. So the deal would be to rather avoid foods that cause the inflammation. So things like trans fats, our refined sugars, our refined carbohydrates, even omega-6 rich foods, rather than the cholesterol-rich foods, which, things like eggs and butter and red meat and organ meat, etc. And we also know that our refined carbohydrates, our high GL foods, food that spike our blood sugar levels, cause inflammation in the arteries, but so do the artificial foods, things like trans fats and binders and fillers, etc. Because, it actually activates the immune system because the body doesn't recognize it as food. So then the first line of defense, which is inflammation, is triggered. Okay. So what happens, and you can see how it kind of was detrimental to our health. the fact that saturated fat was taken out of our diets, and this resulted in us including more trans fats. Trans fats is what you would typically find in margarine, right? But the truth is that our human physiology needs saturated fats. And like I've explained, it's such a huge component of something like breast milk. So the fact that we took that out and included an artificial fat that has been, chemically processed, not really ideal. So I want to explain to you the difference between how saturated fats and trans fats are used in the body. So saturated fats are essential for the function of the cell membrane, like I explained, the structural integrity of the cell, right? While trans fats actually interfere with the function of the cell membrane. So it stiffens the cell membrane too much, which means that the communication can't take place in the way that it should, which is really detrimental. Also, saturated fats enhance hormone production. Like I've explained, it's the building block of many of our hormones, but trans fats interfere with hormone production. Saturated fats suppress inflammation, while trans fats encourage inflammation. Saturated fat helps to put the omega-3 fatty acids into our tissues and preserve it, while trans fats reduce the levels in the tissue. In diabetes, saturated fats help our insulin receptors, while trans fats inhibit our insulin receptors. Our immune system is enhanced by saturated fats, but is suppressed by trans fats. So you can see how, on many different levels, it really was maybe not the best move. And then we still see that lovely Heart Foundation sticker on the margarines, which I find is quite a bit shocking. And they've shown that even small amounts of trans fats, just 2% of our total energy intake, have been linked to an increased risk in heart disease specifically. So yeah. So I think with this info, we're kind of starting to get somewhere, right? So it's more the refined carbohydrates, it's trans fats, it's other artificial substances that cause inflammation in the arteries. And that then causes the liver to produce more cholesterol in order to help with the healing. Okay, so this can help us to understand a bit more about the mechanisms around this. Okay, so now that we know what causes cholesterol, now we need to take the next step in figuring out whether cholesterol really causes heart disease. Okay. So if there is inflammation in the arteries and then the cholesterol goes there to help, would that necessarily translate into a greater risk for heart disease? And that study that I've shared with you with everyone that has been admitted for heart disease, and half of them had low LDL cholesterol. So there was no relation there. But how does this make sense then? Because we've been taught the complete opposite. And what is it then that causes heart disease? And I think the answer to that question is not necessarily that simplistic. It might be more multifactorial. And a question that we could rather ask here is maybe what is the process of cardiovascular disease? Because there's not necessarily one cause and that's it. And there are many elements. There's many elements that have been shown over the year that does increase our risk of heart disease. And I'm going to tell you about them just now, but you'll see that at first sight, it might appear that they have nothing in common. But I'll share with you just now how they do all link up in the end. Okay, so some of the elements that we know increase our risk of heart disease: smoking, lead, other heavy metals, exhaust fumes, raised blood pressure, raised blood sugar levels, steroids or cortisol, and strain or stress on the system in some or other way. So everything on this list increases the risk of cardiovascular disease because they can all do one of three things. It all comes down to them doing one of these three things, or in some cases all three. They either damage the endothelium, so that's the lining inside of the arteries, or they create bigger, more difficult to shift blood clots, or they interfere with the repair process in some or other way. So it causes inflammation or impacts the repair process. So there was a very interesting study that was done in the UK where they looked at many different factors that had been gathered by GPs on their patients. They analyzed their patients. It was, I think, around 380,000 patients that was analyzed over 10 years to see what causes heart disease. And a lot of things made the list. So I think there was 50 items on the list. And things such as corticosteroids that were prescribed, their age, severe mental illness, kidney disease, socioeconomic factors, they all made the list. But interestingly enough, LDL came 46 out of the 50 items on the list. So it's still there, but it's not the main concern. Okay, so let's go a bit more into detail with the items that are at the top of the list. And let's start with blood clotting. So one hypothesis is that, the blood clots or clotting, they're key players in cardiovascular disease because the plaques and the narrowing of the arteries are remnants of blood clots. So that's the hypothesis, that it's the blood clots itself that are causing the narrowing of the arteries. But we do know that blood clotting is linked to heart disease. It's just the hypothesis in terms of why or how as well. So this is just one of the ways to think about it. So the process starts when, once again, that lining of the artery wall is damaged. And this then stimulates the formulation of a blood clot, which covers over the area, almost like a scab, when you damage your skin. And then that repeated blood clotting at the same spot will then lead to plaques getting bigger. And they will then narrow the artery and they will constrict the blood flow. And if your blood is more likely to clot, and if clots are bigger and more difficult to shift, it just means that damage to the endothelium will be magnified. Okay, so if this is the case, then it would be more important to figure out what causes the blood clotting. And what we know is that physical stress, dehydration, not moving, acute mental stress, or non-steroidal anti-inflammatory drugs have an impact on blood clotting. And just an interesting mention on the acute mental stress. So why it causes more blood clotting is because your primal brain senses that it's under attack. And then it typically prepares your blood to be ready to clot for in case you're wounded, which is such a lovely, survival mechanism. But obviously, if we're just trying to meet deadlines in front of your computer, that's not ideal. And then our non-steroidal anti-inflammatory drugs, might be familiar with them. They're typically used for pain, for arthritis, for something like ibuprofen or Voltaren are good examples of that. And something that could be quite beneficial is, of course, our anticoagulants. So things that reduce blood clotting. And of course, there are some medication that you can use for that, but our fish oils or our omega-3s is really great because it has no increased bleeding risk attached, which is a much safer option. Okay, so something else that is worth to look at is our faulty repair systems and how that could lead to heart disease. So why I've got the picture of this road on this slide is, if you live in South Africa, and I know not all of you do, but for those of you who do live in South Africa, you'll be very familiar with the pothole issue that we're facing on a daily basis, right? And what's going on there is there's this ongoing battle between damage and repair, right? If repair is happening, if the maintenance is done on the roads and it's happening faster than the damage, then all is well, right? And we would have lovely use of our beautiful roads. But if damage is overwhelming the repair, then things will end badly, right? And if no maintenance is done on the roads, then we can easily end up with massive potholes, which, is so big that cyclists can even get lost in there, that's what's happening over here. So the same thing happens in the arteries, where if repair systems can keep pace with damage, then all is well. But if damage outstrips repair, all hell can break loose. And which is why, just as a side note, age is such an important risk factor for cardiovascular disease, because as we age, the rate of damage may not increase, but the repair system starts to fall apart in several different ways. And this is why, as you get older, we really need to try to reduce damage as much as possible, because the repair systems might begin to stumble. So once again, what's worth looking at here is what causes the damage, so we can actually help our repair systems to keep up. And I've listed it here for you. The first one is raised blood sugar levels, so our type 2 diabetes, because our increased blood sugar damages that slippery protective layer that covers the endothelium. So it causes quite a bit of harm there. Smoking causes quite a bit of damage because there's a large number of those nanoparticles that find their way into the bloodstream and they attack the endothelium. And this damage does not take years to build up. It's virtually instantaneous. So yeah, it happens quite quickly. Then we've got air pollution, we've got raised blood pressure, we've got prescription drugs, we've got the trans fats because they're pro-inflammatory, as I've discussed. So yes, sure, we could look at what we need to avoid that cause damage or inflammation, but we could also include more foods that have anti-inflammatory or antioxidant components. So you could also look at that. Okay, and the next item that adds damage to the body is stress, and specifically the stress hormones that are released, such as cortisol. But why is this? So cortisol, is the main catabolic hormone. What that means is it breaks down. So it stimulates the breakdown and release of energy stores. Okay, and this process is known as catabolism. Okay. And this is because cortisol is one of that key fight-flight hormones, where if you need to run, if you need to fight, cortisol will have your back. It will make sure that you have the energy to do so. And that is why it breaks down everything, anything it can find in the body to use as energy, it's going to break down. So it stimulates the synthesis, it stimulates the release of glucose, of the stored energy in the liver, which is known as glucogenesis. You might have heard about this. It also breaks down protein to make more glucose for energy use. And it can also drive the release of our fat stores. And specifically the fat in our the subcutaneous fat. So that's the fat that's found underneath our skin. And this then leads, so it's breaking down all of these elements, and this then leads to an increase of free fatty acids in the bloodstream, right? And when they reach the liver, they are then further broken down into ketone bodies. So you might have heard about the whole, ketosis thing where we use our fat stores as energy. And this is then another easy to use energy source if you need to run, if you need to fight. So it's basically breaking down everything. And then all of these released energy stores, that's excellent if you are actually going to have that fight, right? So then you are going to use them, or even if you have a gym session, you use that energy, everything that's broken down. But unfortunately, if we have these prolonged cortisol levels for longer periods of time, all that extra glucose, all the extra free fatty acids, they're just going to slosh around in your bloodstream and they cannot be used. Okay, which means that they must find somewhere else to go. So firstly, they are going to cause that extra glucose in the arteries, is going to cause extra inflammation. But also that stored energy from the fat underneath the skin and even from the muscle is going to be moved to visceral fat. That's your harmful fat around the organs, right? They're typically that you store around the middle or around the abdomen. So cortisol does not only make you fat in the middle, it moves around your fat. Quite interesting, hey? But it also makes you more resistant to insulin because because cortisol is a direct antagonist to insulin at all sites of action. And this is not surprising, as insulin is an anabolic hormone. It's completely the opposite. Cortisol is a catabolic hormone. It breaks down. Insulin is an anabolic hormone where it stores the energy, right? So this could lead to a system-wide battle, which could impact several different systems in the body, and even cause something like insulin resistance, which we know is the main underlying cause of type 2 diabetes. So finding the things that bring balance to the system would really be key here. So things like relaxation, our meditation, our mindfulness, and yoga. And I'm not just saying this because it seems like they're nice things to include into our life, but because there's really good evidence, and specifically related to heart disease, that they can all be highly beneficial. There was one German study that I can think of now where the researchers looked at specifically the benefits of yoga following a heart disease, or a heart attack, actually, following a heart attack in men. And it was found that their systolic blood pressure could be lowered by up to 21 millimeters of mercury using yoga alone, right? And that's a damn sight better than almost any single blood pressure lowering medication. So quite a lot of science around, to back that up as well. And then just the last thing that I want to mention on stress is that the research reveals that chronic stress can increase the risk of a person suffering a heart attack by almost twofold. So it basically doubles your risk if you are experiencing chronic stress. And then it's also linked, I need to mention this as well, because it's also linked to stress in social isolation. Okay, so the impact of loneliness. So loneliness, the impact that it has on health and our lifespan. When you are over 50, it seems, and you're experiencing severe loneliness, it is the equivalent of smoking about 20 cigarettes a day, which of course is another major risk factor for a heart attack, right? And also dissatisfaction in marriage. They've shown that the marriage quality can also play a significant role, because there was a study where they followed women in Stockholm who were followed for up to 5 years. And they showed that the chronic marital stress was associated with an almost threefold increased risk of a heart attack or stroke. So isn't it interesting how it's more of a holistic approach as well? There's a lot of other things that play a role. It's not just what we put into our mouth. And that's our job as health coaches, is to support people to become well in all areas of their life. And this is what is really going to add to them reducing their risk of these types of disease. Okay, the next element that I want to look at is raised blood pressure. So we know there's many millions of people who have high blood pressure, and it just batters away once again at the endothelium cells, so day after day. And just an interesting note here as well, that know that if your blood pressure falls, your sodium levels will also fall. So the kidneys then take immediate note, the sodium levels are down, and then they release all kinds of hormones. And those hormones then narrow the arteries. It stops the water and the sodium being released from the kidneys, trying to retain more sodium. So obviously, if the arteries are narrowed, once again, that's going to impact your risk for heart disease as well. Okay, and the last one that I want to touch on here is lack of adequate vitamin D. And where, the chronic stress and even marital dissatisfaction, it maybe increases your risk twofold, threefold. But the lack of vitamin D, interestingly enough, is associated with an almost sixfold increase in the development of heart disease. That's quite huge. And unfortunately, the deficiency in vitamin D is becoming more and more common across the whole world. And even in countries that are closer to the equator, or countries that do have a lot of sunshine. And this is because people they tend to spend more and more time indoors. So we know that 90% of the vitamin D in our bloodstream comes from exposure to sunlight. And we know that cholesterol is needed to convert the sunlight into vitamin D. We also know that high sugar diets reduces the ability of that active form of vitamin D, that's vitamin D3, to work effectively in the body. So you can see how this is just the perfect storm with all of these different elements that hinders our ability to have enough vitamin D in our blood. Okay, so we've looked at what might be causing heart disease, but what will reduce your risk? So we're just going to look at a few elements here, what it is that you can do that is within your control. Okay, firstly, so I've been talking quite a bit about the endothelium and how it gets damaged. So it's kind of obvious that if we protect the endothelium, that it will reduce our risk of heart disease, right? So where a high glucose or a high sugar level is damaging, a high protein level is protecting, even a high fat level is protecting, because it provides the raw material that allows it to be kept strong and healthy. And the endothelium needs protein to make it, to repair it, to replenish it. So that's a very important shift that you can make, just making sure that you having enough protein, enough fats in your diet. And then next, nitric oxide. So I wonder if you've heard about nitric oxide before. You can maybe share in the chat box if you have. But it's really impossible to overstate the importance of nitric oxide on cardiovascular health, because nitric oxide dilates narrowed arteries. So it's really so powerful. It also lowers blood pressure by opening up the arteries elsewhere in the body as well. And it's a very powerful anticoagulant agent, which means that it prevents blood clots, right? It even improves insulin sensitivity. So you can see with all the risk factors that we've discussed, it kind of addresses all of them. So anything that reduces nitric oxide's production will increase the risk of cardiovascular disease, and of course, vice versa. And once again, the action of sunlight on the skin, for example, creates nitric oxide. So once again, the importance of getting outside. So how do we increase nitric oxide, and where do we get it? So one of the elements, or one of the things you could do, is more exercise. So the more we exercise, the more nitric oxide synthesis. Relaxation techniques that helps with that, increased sun exposure, breathing through our nose, quite an interesting one. And then some veggies, some fruits and veg contain quite a bit of nitric oxide. So just a quick mention on breathing through the nose. If you breathe through your nose, nitric oxide actually gets into your lungs and your blood vessels. And that dilates, once again, the airways and the blood vessels in the lungs and elsewhere. And Cleveland Heart Lab, you might have heard about them, and they said that it's so beneficial to take long, deep breaths through your nose because it helps to release nitric oxide, which has been shown, and this is listed on their some of their platforms. They say that it expands our blood vessels, it increases blood flow, lowers blood pressure, reduces stress. Reduces stress and produce an all-over calming effect, and it prevents the build-up of artery clogging play. So quite a bit of a magic food even. And we can eat to increase nitric oxide. And there's quite a few vegetables and fruits that contain quite a bit of nitric oxide. And I think top of the list is probably beetroot. So beetroot contains a lot of nitric oxide, and it's also extremely beneficial for sports performance. So for those of you who are interested in that area, the more nitric oxide, the more oxygen is actually available to the muscles, which really helps with the performing and the elements of increasing your performance when it comes to your sport as well. Also a bit of nitric oxide in garlic, our leafy greens, citrus fruits, nuts and seeds, watermelons, but beetroot is definitely top of the list. Okay, what else can you do to reduce your risk? So short bursts exercise, also very beneficial, and this is because short bursts of intensive exercise burns glucose most. So that's our sugar, the things that are causing the inflammation in the arteries, and our short bursts are anaerobic, which means that it does not use up oxygen and it relies entirely on using that sugar. So it's only going to use the sugar instead of fat for the fuel, right? So if it's maybe a longer cardio session, then it's more going to tap into your fat cells probably. So if you burn the glucose with a short burst, then it's going to help to manage the insulin, reduce the inflammation, etc. And then the last one is the dietary fiber. So we also know that dietary fiber is associated with a lot of cardiovascular benefits. I think when it comes to food, it's really about making sure, once again, it kind of comes down to the same thing, where we need to include more variation, right? The more variation we're getting, the more different nutrients, or how, we can make sure that we are getting all the different nutrients that we need, that we've discussed today, and getting enough fiber to also protect the heart in that way. Okay, so what if, so let's say your cholesterol levels are high and you are worried. What other tests are there that can maybe give you more peace of mind and is maybe more reliable in terms of whether you are at risk for heart disease? So something that I found is very reliable here is the coronary calcium score. And you can share in the chat box if you've maybe experienced the same thing, if you've maybe did this test yourself, or if you're a doctor, if you would recommend it. But what it basically does is it measures the degree of calcium buildup in the coronary arteries. And it's a 5-minute test. It's done with low dose X-rays. And then that calcium that's found in the coronary plaques is also a marker of inflammation, within the arteries. So you can see here on the screen, 0 to 100 is a low risk, 100 to 400 moderate risk. You can read through that. But what's really interesting here is that there's no significant change in the progression of the calcium score in patients taking statins. So even at the highest doses, and despite significant reduction in LDL when they take the statins, there's no change in the coronary calcium score usually. So more consistent predictors are typically your progression or more consistent predictions of the progression of the coronary calcium are high blood pressure, diabetes, high blood triglycerides, smoking, and low HDL cholesterol. So those are the things that seems to be directly linked to heart disease. Okay. All right, so I want to end off the presentation with what the dangers of low cholesterol are. So typically we tend to focus on the dangers of high cholesterol, but and of course I've discussed this throughout the webinar, where it's definitely an integral part of our overall health. But one interesting area that we maybe haven't touched on yet. So there are people who are unable to produce enough cholesterol, and they seem to be more prone to emotional instability and even behavioral problems. And low blood cholesterol has been routinely recorded in criminals who have committed murder and other violent crimes, or people with aggressive and violent personalities, people who are prone to suicide and even aggressive social behavior and low self-control. And there's this quote on the screen from the late Oxford professor David Horrobin. And he said, reducing cholesterol in the population on a large scale could lead to a general shift to more violent patterns of behavior. So there's also another interesting link there. So, many studies have found that low cholesterol could be, in certain respects, even worse than high cholesterol. So we just need to consider this as well, and maybe start to shift our perspective a bit on only demonizing the high cholesterol levels. Okay, so our key takeaways, and in summary, we need cholesterol. Without it, we won't survive. And cholesterol is a healing agent in the body, and the real culprits are inflammation, damage to the endothelium, the blood clots, and interference with repair processes. And lastly, low cholesterol could even be damaging to the system. Okay, so I actually made it within the hour. I thought that I would have to go over time. But yeah, thank you very much for joining me. And I really hope that, you all have a really lovely festive season, and that you maybe take some time off and spend time with your family, and just really reduce your risk for heart attack by reducing your cortisol levels, right? And getting plenty of sunshine, spending time with the people you love. And I really look forward to connecting again with you guys in the new year. So thank you for joining me. I am going to stay on for 2 minutes, maybe, to see if there are some questions. But yeah, thank you very much for joining me.